Thank you, Iulian. Hello, nice to see you all here. I'm going to talk a little bit about our smart contract release process. So most of the projects that are deployed currently on our blockchain are using at least one smart contract. Some of them might have tens, some of them might have even hundreds of contracts. I know for sure that, for example, our exchange just passed 100 contract last December or so. So I only know what a nightmare that brings to actually develop and also deploy all those contracts. So clearly, you need special handle and care for this deployment and development process in regards to smart contracts. As in the lifetime of a contract, some of them might only see one deploy and then that's it. But some others might also have some subsequent upgrades in order to bring new functionalities into the smart contract or maybe fix some issues in time. I'll show you now some of the practices that we have internally for managing these smart contracts and also the tools that we use and also are publicly available so you can use them as well to improve your processes. All right, so similarly to the way Iulian presented for the protocol side, we have some strict control of the code changes. So each code change has to go into a branch for any of the repos that we have publicly for smart contracts. Each branch has to actually be merged via pull request. Each pull request has to be approved via human reviewers, either internal or external. Alongside the reviews, we also have GitHub actions that are running the test cases that are available for the release, as well as linting for the last code, build of the code to make sure that the code is still building, and also some statistics, for example, to see whether your contract is getting larger or smaller and so on. Now, if everything is passed on this side, then the next step is to have either external audits in some cases, and of course, we are running some additional test cases on real chains, like testnet or a cloned version of the mainnet. For example, this is useful when you are actually doing upgrades. It's particularly useful to make sure that your contract does not actually break at the upgrade, so you do not alter the state of the contract, for example, and then to also make sure that the contract still functions as well. And it's also, for example, useful when you are dealing with large number of contracts as well. So, for example, when you're using other contracts from the community and so on. If this is passing as well, then we have a certainty that this is a stable version of the contract, so we do a GitHub release of that specific contract. So when we deploy the contracts on the chain, we only use smart contracts coming out of releases. We do not use local builds because local builds cannot be, I mean, in some cases cannot be proven that they're actually coming from your source code, and we'll see how to deal with this as well. Okay, so what does a smart contract release contain? In this case, we have two parts. So the first part is what's caught under the commit hash. So this would be what's in the repository. So we only store here the code, configuration files, and so on. We'll talk a little bit more details later. And the second part is some reproducible build artifacts. These are done automatically and attached to the release. We'll talk about them. Now, for what's in the repo, I just mentioned that we usually keep the contract code, configuration files, so everything that's needed to actually build a contract, but we do not store the binaries. One important thing here is that we also store the cargo log files. You might also go without the cargo log files because in normal builds they're just automatically generated, but we want to store them because further on, in order to have a reproducible release, we do something called a locked version build. These cargo log files are specifying versions for each of the modules that the contract is using, either developed by your own or from the framework side and so on. Okay, so the second part of that release, I was mentioning, these reproducible build artifacts. This is done automatically via a GitHub action that it's triggered when we create the release. So this GitHub action is actually producing the WASM binaries that we're going to deploy. It stores also the code hashes of the produced WASM binaries into the release. These are useful for traceability. When you're looking at the contract, for example, on the Explorer, you can take the the code hash, sorry, and then just look into the repo in what release it was stored. Further on, we also have here some contract verification by products. And these are some nice things that we'll talk a bit about later, and we'll see why these are useful and also really nice. All right, I mentioned several times these reproducible builds, but how do we actually do it? Rust by default is not supporting a reproducible build. This means that when I'm building it on my machine and building it again, I will actually get, in most cases, to the same WASM binary. But if I'm building it on another machine or different paths on my machine, it might get you a different WASM binary. And this is not good when you want to have reproducible builds. So what we did to actually solve this problem, we've created a Docker image that is building any contract that you give in the same environment. So in this stable environment of the Docker image, we always get a reproducible build. So in order to make it even more easier to use, we've incorporated this Docker image into MXPy. So similarly to how you did MXPy contract build, now you can do MXPy contract reproducible build, just specify the version of the Docker image, and then voila, you have a reproducible build. And this, as I said, is reproducible on any machine, any paths, every time. Now, further on, we also included this Docker image into GitHub Actions. And this is actually what's powering that automatic process of actually building the code and attaching the artifacts to the release. These GitHub Actions are available at that link that I specified over there, so you can right away use them, just copy from over there, paste them into your repo. You don't even need to modify them too much, and then they're just usable. Now, I'm not sure exactly how many of you have seen this page, because normally for a smart contract that's freshly deployed or upgraded, it looks like just code hash and then a large chunk of binary WASM file. This is actually the Explorer page of a verified contract that we mentioned. Yeah, we call it verified. And it's showing you the code of the contract in the Explorer, endpoints, events, types, and so on. And I think in the future, it will actually incorporate even more features. Why this is actually very important and necessary on our side is that we want to show to the users of the smart contract that what we claim the contract is doing is actually what the contract is doing. And they can actually get this proof by themselves. They can look at the code, they can see how they can operate the contract without the interface and so on. So, how do we get this? I was mentioning those contract verification by products. So those are actually one JSON file that's produced by the Docker image for each smart contract. And this JSON file is actually incorporating the entire source code of the smart contract that you're building, along with some metadata. And then you can take this JSON file and give it to one of our Explorer services. And this Explorer service will actually build that file. So it will build your source code that you give. And if it gets to the same code hash than the one stored on the blockchain for the smart contract that you're trying to verify, then clearly that's the code for that specific smart contract, so it will automatically create that page. How do you do this? So we made it easier. You just use mxpy, contract verify, give it the address of the contract you're trying to verify, the PEM of the contract owner, and the JSON file as well. Specify the path of the service, and then if it gets to the same result, as I said, it's automatically generated a page for you. Now, to conclude the presentation, the things that you can right away take with you are these 3 links over here. So the first 2 are MXSC actions and an example of the reproducible build repo. You can take the actions from over here, use them into your projects. We very much encourage you to do so in order to improve the processes. And of course, the last link, it's our documentation for this reproducible build and also the contract verification side. Thank you very much. Keep building and hope you have a good xDay.